Welcome to the second episode of This is Bitcoin. Um, Now, while this may seem like an unlikely place to start, we're going to start today in the NET.cpp source code file. And the reason for that is pretty simple, that the difference between Bitcoin and your own separate altcoin has to do with whether you all connect to each other or not. And that's done with the net command. See, when you fire up your Bitcoin wallet, it needs to find the rest of the Bitcoin servers out there. It doesn't have to connect to all of them, but it has to connect to some of them. And they all share and communicate amongst each other. If you create an altcoin, one thing you do not want it to do is connect to a bunch of Bitcoin servers. You want your coins to only connect to your clients and not connect to some other coin's clients. It wouldn't work anyways because your blockchain, which is a descendant blockchain from an original Genesis block that started your blockchain, would not check out properly because it's not the same Genesis block that Bitcoin started with. And so anything you tried to do connected to some other blockchain's connection would simply get rejected. So you want only your peers, only your clients to connect between themselves. Which brings us to the question of how do Bitcoin clients find each other? And that is done in this net block. Now, it looks like a lot of really complicated code, but you'll see some of these processes basically says, look, I'm going to connect to one or two seed nodes because once it connects, I'll get a pile of addresses with newer stamps. Seed nodes are given a random last seen time of between 1 and 2 weeks ago. Okay, so you have to connect to seed nodes. And these seed node addresses are either hard-coded into your system or can be pulled from seed DNS servers, DNS locations that are also hard-coded in so that you can get your first connection to someone else in your Bitcoin group or in your altcoin group. Bear in mind that you have to set up your own seeds, you have to set up your own DNS seeds, you have to make sure that there are a group of peers out there and that everyone running your client can get connected to your peers and that they won't find or get connected to some other coin like Bitcoin or some other altcoin, because obviously that won't work if you're creating a new coin. Now, one of the things that the coin has to do is give other people, other clients, that the lists of addresses that it passes on, just like a client passed on to you. And among those, of course, is your own address. That seems simple, but in fact, there has to be an address discovery system because your machine sees itself as 127.0.0.1, and it's probably behind a router on a dynamically assigned local unroutable address, but when it peeps out through the internet, it is actually appearing on a real IP address, and it needs to share that if it's going to be able to have other nodes connect to it. And the idea of a peer-to-peer network is everyone can connect to everyone, and so you have to learn your local address, figure out, you have to map your local host address, and then make that available on the lists of addresses that you pass out to other servers so that every server knows how to connect back to you as well as you knowing how to connect to them. So this seed system, which I'll get into in more detail later on, has to be completely created for your coin. You have to maintain the seed, uh, some seed servers, and you have to maintain the DNS seed that passes out the IP addresses of the latest and current stable seeds. All right. In much of this, um, you'll see functions opening up ports and addresses, which basically are programs that talk to your Ethernet connector, to your Ethernet card, or in a Wi-Fi scenario, to your Wi-Fi Ethernet connection. Um, and there you bind to a socket. You create a socket, you occupy a port, and then you create a connection, and your Ethernet device will make whatever comes in that appear to be blocks of data, almost like reading a file or writing to a file, but in fact it's a pipe going out to whatever is connected to the opposite end of that connection on some other machine over the network. In most clients, they try to detect if there's a proxy and work through that proxy. As you see, this code is making those attempts. There has to be some random stuff to protect yourself. So we use a random key, and then we use that as an end connection that we know will be unique to us. So when the connection comes back in, other things on the computer won't receive that data, but the data can go directly to the calling program, which would be the executing, the net executable, which would be compiled from this cpp.net file. Okay, we want to find out nodes with good ping times and detect if nodes become lagged or disappear. And we see this as pinging and detecting ping times to other nodes. Now, when people ask me about proximal code, which is a Bitcoin client that only works on a certain island, and if you're 60 miles away from the island, it doesn't work. Well, basically, we just don't we cancel anything that pings beyond us 20 milliseconds or whatever, and therefore, even if it's a slow connection on the same island, it won't work. But since no connections can respond with a ping, traveling the distance to and fro faster than the speed of light, we know with absolute certainty that that particular coin cluster can never be connected to or transacted with from anywhere off that island, because the nearest adjacent island is more milliseconds away. It happens that keeps everybody within one legal jurisdiction, and for legal purposes that might be desirable for a particular blockchain application. Now, most of the messages, some of the messages in here are a little bit vague, but the more you read through these messages, the more it all starts falling together. And you look at the many things that have been done over the years to screw with Bitcoin, creating extremely long messages and huge packet sizes and whatnot. And so code to reject anything that's outside of certain parameters has been part of Bitcoin for quite some time. even in some of the original code. Some lessons had to be learned after the fact. As we go farther down in the file, we find a lot of the background functions. Usually, the more unique and special functions will be put at the top of the file. The order is not really relevant because when it's compiled and then linked, it's all based on a link jump tables anyways. So basically every function is one jump byte distant to some pointer to wherever it ended up inside the object file that it got compiled to. This, you'll see a lot of references to Qt in this particular code because there's a Qt graphic GUI included in it, although clients don't need to have any GUI at all, and they don't really even need to have wallet functionality if all they are is mining. Okay, so we have an inactivity check. Okay. If there is data to send, send. If the remote peer is not themselves receiving data, this means properly utilizing TCP flow control. Now, there's a lot of junk code out there when we go over other altcoins, we'll talk about code that doesn't pay attention to whether the TCP flow control is even being properly done. And this is crucial because otherwise clients all over the place can be getting denial of service attacks and other strange things happening to them as hackers try randomly to hack away, hoping to get lucky and make something fall out or fail, depending on what their goal is. Now, in some cases, an Ethernet card or an operating system can have a limit to the number of sockets it can hold, or it can drop sockets for different reasons. So the socket connections have to be maintained or rebuilt if they disappear. The data traveling out the socket, whatever structure it might be in, must be serialized because sockets are serial communications. As the Ethernet sends one byte after another, one packet after another. But this is all the same code. UPnP for the for finding and discovering a router path out and what your external IP address is. Is implemented. These are the regular UPnP libraries provided for CPP, okay. Only query DNS seed if address need is acute. If you have a reasonable number of peers in your address bank, spent some time trying them first. This improves privacy by creating fewer identifying DNS requests. Reduces trust by giving seeds less influence on the network topology and reduces traffic to the seeds. When querying DNS seeds, query a few at once. This ensures that we don't give DNS seeds the ability to eclipse nodes that query them If we continue having problems, eventually query all the DNS seeds, and if that fails too, also try the fixed seeds. Down in the thread, open connections. So to sum it up, you have to have your own blockchain. You have to create your own Genesis block and maybe building blocks on top of that. You have to mine at least a few blocks of your own to get started once you've made your Genesis block, and then you put out, you establish, you broadcast your seeds and establish some seed servers, and then you start handing out your client, making sure that your client is connecting to your seeds that are all building on your blockchain and that have your Genesis block that they're building on. And that makes your coin, not Bitcoin and not some other coin. What I'd like to do is sit down and go add a huge amount of more comments in here. But I'm sure that it wouldn't be welcome pushed to the regular GitHub server, so it would have to be a private fork where we would actually properly document this. Anyone who wants to volunteer to help with that, just contact me directly, and we can start creating a fully instructional source.